Welcome to Pindar Poetry. We hope you learned something new.
You start by preparing reliable animation data, import your FBX clips at native frame rates, and check root motion. Once done, create a master animation database and tag each clip with attributes like speed, gait, and intent. This helps matching decisions later. Make sure your skeleton retargeting is consistent across sources so poses line up. Normalize transforms into world space to reduce offsets. These steps reduce noise, and they let matching evaluate poses numerically rather than guess from mismatched bones. Now you build the matching pipeline. Extract pose features per frame, joint positions, velocities, contact flags, and a short root trajectory sample. Once extracted, encode pose vectors and insert them into a fast nearest neighbor structure like a KD tree or ANN index so queries run in milliseconds. Make sure to balance the cost function. Prioritize foot contacts and root velocity to avoid sliding, while still considering upper body intent. Tweak weights iteratively. Small changes can significantly alter selection quality. Finally, integrate matching into your runtime. Sample the desired future trajectory, query the index, and blend or warp the selected clip into the current pose using short crossfades and footlock corrections. Once integrated, profile latency and stitching quality. Make sure blending preserves contact frames to avoid sliding. If you see jitter or pops, inspect contact flags first, then reduce noise in pose vectors or increase trajectory sample length. One key tip: always log query costs. They reveal whether your cost weights or features need rebalancing.
Thanks for watching. Consider subscribing if we helped you.